Sorry for a little bit of a delay there. Welcome to APS webinars. The title of today's webinar is Graduate School in Physics, a Minority Perspective. I'm Crystal Bailey, and I'll be your host for today's broadcast. Thank you all so much for joining us. APS webinars are brought to you as a service of the American Physical Society, connecting you with the expertise of individuals who can offer insight into physics careers, educational programs, and professional development for students, working physicists, and educators. Today's presentation features graduate students Ximena Fernández and Collin Joseph, and will be moderated by APS own Arlene Modesti-Knowles. Ximena and Collin will be sharing their perspectives as minority students in physics graduate programs. After Ximena and Collin finish their presentations, the remainder of the program will belong to you for a question and answer session. Because of the number of people attending this webinar, we are only accepting text questions. So if you would like to ask a question, please type it into the chat panel located on the right side of your screen. You may submit questions through the chat panel at any time during the webinar, and we will do our best to answer all of your questions at the end. And we do apologize if we are unable to cover everything. Finally, a link to the recording of today's presentation will be made available on this webinar's main page, which we will share with you towards the end of the broadcast. We do ask that you please allow 24 hours for the video upload. And so with that, let's get started. Moderating the discussion today will be Arlene Modesti-Knowles. Arlene serves as the Career and Diversity Programs Administrator at APS, where she manages several diversity programs, including APS scholarships for minority undergraduate physics majors. She is also in the program management group of the APS Bridge program. At APS, Arlene works on programs and activities that address the recruitment, retention, mentoring, and careers of underrepresented groups. And with that, I will turn things over to you, Arlene.
Thank you, Crystal. Can you hear me? Hopefully you can. First, as Crystal said, I want to welcome you to the APS webinar conversation here on Graduate School in Physics from the Minority Student Perspective. As Crystal mentioned, we have two graduate students, Ximena Fernández and Collin Joseph, and they're from schools on both the eastern and western U.S. coasts of the United States, and they'll share a little bit about their backgrounds, their experiences getting into graduate school in physics, what they're studying, and how grad school has been for them. They'll also share some tips and advice for prospective students. Each will speak for about 15 minutes, and then we'll take questions, as Crystal mentioned. And when you do type them in the chat box, just be sure to select organizers so that we can see your questions and not everybody who's listening to the broadcast. Okay, so with that little bit of housekeeping done, I'd like to introduce you to our two speakers. I'm really thrilled that they're here. Ximena Fernández is a graduate student in the Department of Astronomy at Columbia University. Her research focuses on galaxy formation and evolution. In particular, she studies the neutral hydrogen content of galaxies and how it changes in different environments. She did her undergraduate studies at Vassar College in Physics and Astronomy and at Dartmouth College in Engineering Sciences. She then applied to Columbia's Bridge to the PhD program to improve her preparation and get a better sense of what graduate school was like. As a Bridge participant, she got a taste of graduate school by doing exciting research and taking classes, affirming her interest in pursuing a PhD in astronomy. And we're very happy that she's here with us today. Collin Joseph graduated from Yale University with a physics degree in May 2008. After graduation, Collin was interested in acquiring more hands-on training in a lab and decided to work as a lab technician at Hampton University, building detectors for Minerva, which is an experiment that's designed to learn more about neutrino nucleus interactions at Fermi National Accelerator Lab in Batavia, Illinois. He helped implement a new process of adhering the fiber optics that carry data to connectors for photomultiplier tubes, or PMTs. Although Collin enjoyed his work in experimental particle physics at Hampton, he decided he wanted to pursue soft condensed matter in graduate school. Now, as a fourth-year graduate student at UCLA, Collin is pursuing research in the properties of biological materials, more specifically exploring connections between the dynamics of conformational changes in proteins and their chemical function. And now I'm going to ask Ximena to give her presentation. So. With that, I'll turn it over to Ximena.
Okay, so can you see my screen? I think so. Okay, I would like to first thank Arlene, Bushra, and Crystal for organizing this and for inviting me to talk about my research. So I'm doing my PhD at Columbia University in Gas and Galaxies. The background image shows a beautiful image of the VLA, and I'll talk about that in a second. So first, I would like to start describing my research, and then I'll tell you about my grad school experience. We have here showing images of galaxies. I'm interested in galaxies. Galaxies are gravitationally bound systems of stars, dust, and gas. And if we were to see the Milky Way, we were to leave our galaxy and look at it from the top, we would see a spiral disk, such as the image I'm showing on the left. And then galaxies have very exciting lives. They interact, and they also have black holes. So I'm interested in understanding the growth and evolution of galaxies. And to do this, I'm studying the gas properties of galaxies. So you might think, how do we observe this gas and what does it mean? So we know that a hydrogen atom has a proton and an electron, and the spin is usually aligned. But when the electron flips its spin, a photon is emitted at 21 centimeters, and to observe that transition, you would need to use a radio telescope, which is long wavelength regime of the electromagnetic spectrum. So here I'm showing my two favorite radio telescopes. On the left, you see the Arecibo Observatory, and to the right, the Very Large Array. I've used both, and in my undergrad, I used Arecibo, and now for my thesis work, I'm using the VLA. So the difference between the two is that Arecibo is a big dish, so it's very good for sensitive observations. So it has very good sensitivity, but the resolution is not that good. So if you want better resolution, you go to the Very Large Array that has 27 dishes, and you can move them around for different spatial resolutions. And you might want to ask, why would you be interested in studying the gas in galaxies? There are many reasons for this. The first reason is that the gas in galaxies is the fuel for star formation. And it also probes the internal properties of the galaxy and the environment as well. So here on the left, I'm showing an image of the M81 group. As you see, and optically, it looks very different than what you see to the right, which is the gas distribution, the H1. As you see, the galaxies are interacting, and you will have no idea that this was happening if you only looked at the optical image. So most of these observations have been done locally. And the gray circle shows where we've observed galaxies in H1. And this is a redshift distribution diagram of galaxies in the universe. So we've done things only very locally, redshift of 0.08. So redshift is a measure of distance. And with new improvements in radio telescopes, we're starting to probe larger volumes at larger distances. So the blue, the cyan rectangles show new surveys that have been done. And the purplish cones show the projects that I'm involved in. So when we're right now working on the proposal to observe the H1 from redshift 0 to redshift of 0.5. But right now we have data for a pilot that went to redshift of 0.2. And what that means is that we're able to observe galaxies that are 3.2 billion light years away. And once we have the full time, we'll be able to observe galaxies that are 9.2 billion light years away. So just to show you one of my detections before switching topics, this is an optical image, the grayscale, and I'm overlaying the H1 contours. And this galaxy is at redshift of 0.12. And to get there, it will take us 1.8 billion light years. So it seems not that far away for other people, but for the H1, it's a big deal. So that's what I'm doing right now. So I'd like to tell you what I've done so far. So I'm originally from Colombia. I moved to the U.S. a while ago, and I did my undergrad at Vassar College, which is a small liberal arts college in Poughkeepsie, New York. I really enjoyed my time there. It was a small school. There were great professors, and there were also really good research opportunities. So the first summer after my sophomore year, I went to Wesleyan University. Vassar is part of a consortium of universities where they exchange students. So I was part of that exchange, and it was great. I loved that experience, and I was really interested in pursuing astronomy then. And then after my junior year, I went to Arecibo, and that was also a fantastic experience that actually became part of my senior undergrad thesis, and that eventually became a paper. So it was a very productive and fun experience. And then after graduating from Vassar, I went to Vanderbilt to work for a summer with Kevin Stassen, and my main job was to observe. He took me to Chile, and I spent a month there observing. But then during Vassar, I was also not sure if I wanted to pursue astrophysics or engineering. I really enjoyed the research I was doing, and the research experiences were really fun, but I wasn't sure about the future. I wasn't sure if I wanted to be a professor. I thought engineering opened more options for me. So that's why I went to Dartmouth. Vassar and Dartmouth have a dual degree program where you spend 3 years at Vassar and 2 at Dartmouth, and you end up with 2 degrees. So I just decided to try it out and decided to complete it. I actually wasn't extremely happy. I think location was a big thing. It was very isolating, and it's very important for me to be near a city. And also, I didn't enjoy engineering that much, but I still decided to complete it because I thought it would be good for my career. Then, by accident, I went back to astronomy. I actually came to New York for an engineering career fair, and I was looking for a job. And I was visiting a friend here in the astronomy department, and he introduced me to Marcel, who was in charge of the bridge program. And Marcel told me about the bridge program, and he was like, well, maybe if you want to go back to astronomy, you can apply to this program. And then I applied, and I got in, and it was a really good experience. It was my transition back to astronomy. I took many classes. I did really good research. I had the opportunity to interact with faculty, and it almost felt like I was a grad student already, and I really got a sense of what graduate school was like. So it was a great experience, and then that kind of made me go back to astronomy, and I was very happy about it. So then I applied to grad school. I was pretty sure I only wanted to be in a city. I realized that was very important for me. So when selecting which schools to apply to, there are many factors to consider. Of course, one of them is what kind of research you want to do. Also, personal life. For some reason, you want to be near family or loved ones or whatever. And also, location was very important for me. And once you have the list, I think it's very important to network. So I think I applied to 7 schools, and I ended up getting into the places where I knew people, where I had actually talked with people. Places that didn't know me didn't accept me. So that's one of my tips. So grad school, I decided to stay at Columbia because I had taken many classes already, and I love New York, so it seemed like the right decision for me. The transition period was relatively easy since I was already here, but I felt that I had to take more ownership on my research, which was, I think, was a challenge the first year. But then I think things have improved since then. I think throughout grad school it's very important to have a balanced life, just not be doing research all the time because you can go crazy. So I do things for fun, like go running and things like that. I also think it's very important to attend the department events so people can see you, and you can also learn from all the events. Colloquiums, seminars, or like even social events are very important. And also, I think it's important to talk with people, especially asking for help if you're stuck with something. Don't be stubborn and go ask for help. And attending conferences is very important, and networking, of course, because you have to start thinking about what's coming next. Life after grad school, I probably want a postdoc. We'll see. I'm kind of in the middle of it, and then, but yes, I want a postdoc. And then now, before getting here, I didn't know getting a faculty job would be that difficult, so I'm a bit worried about that, but we'll see. There's still time. And that's it for now.
Okay. Ximena, thank you for that presentation. No, now, Collin, I'd like to turn it over to you.
Yes. Hi. So, hold on, let me go back to my first slide. So I'm going to talk about my journey to grad school from neutrinos to proteins, because I switched fields from particle physics, neutrino physics specifically, to the biophysics and soft condensed matter, which I think is an important experience for you to understand. So the first thing I want to talk about is why physics. Right? Because when you're going to grad school, you really have to have a good idea what your motivation is for being there and why you're going to be there. And this can also help guide you choosing a subfield and deciding what path you want to go. So there are a lot of different motivations to do physics grad school. Sometimes you just want to explore the universe. Maybe you want to pursue a fundamental simplicity. Maybe you want to teach. Sometimes you're attracted to difficult problems. And all these kind of motivations exist in different proportions in each student. And it's important to have a good understanding of what these are if you're going to select a field or a group that's right for you, that you can get something done and something worthwhile to contribute to physics. Okay? So let's talk about what you do in your undergrad years. Sometimes, for me, for example, I was interested in physics going back to an early age, in science in general. I think we all as kids are very curious and interested in learning about the world. And for me, that translated into science and math. And when you hit undergrad, you immediately, at least for me, going to Yale, I was immediately struck by the breadth of the field. It extended much beyond what I thought existed. I was mostly interested in particle physics when I entered undergrad, and I was immediately struck by the rest of it, and that there's condensed matter, solid-state physics, nuclear physics, all these other things that you learn about going to talks, attending department colloquia, which are usually pitched for undergrads anyway. So you learn a lot about just the state of the field that way. Secondly, as Ximena mentioned, you really should get involved in research. It's probably the most important thing you can do as an undergrad to both prepare yourself for grad school, both your application and yourself mentally and mentally for it. If you're at a smaller school, you can and that doesn't have the best research opportunities available for you. There's the NSF runs a program called the Research Experience for Undergraduates, abbreviated here as REU. You should probably do, in that case, you get to spend a summer, 10 weeks, 10, 12 weeks at another university getting involved with some research with some well-known and very good people. You can get some very good research experience that way. Even though I was at Yale, I did take a summer and go to U Chicago to get experience in condensed matter physics, solid state, specifically granular materials. And that was really important for me, developing my interest in condensed matter physics outside of particle physics. So let me briefly talk about what I did in undergrad. So in the picture here are our two postdocs, Alessandro on the left and Mitchell on the right, and they're lowering the detector we built, the TPC, into the vessel with liquid argon in it to cool it down so we can detect neutrinos. So my part in this was twofold. I assisted the group in actually building this detector and testing it and cooling it. We were the first group in the U.S. to make this new kind of detector, liquid argon TPC, which we're proposing that the next generation of big particle physics detector is liquid argon TPC to do neutrino physics for various reasons. And also, I did a theoretical project determining what we expect to see from these detectors. What limits can we set on various physical parameters? So my project was actually mostly theory based on this. So as Arlene noted in my bio, I took a year in between undergrad and graduate school. And I decided to do this for several reasons. Firstly, I had that secondary interest in condensed matter physics that I really wanted to explore because I wanted to explore that. Secondly, I had applied to graduate school in my senior year of college, and I didn't get into any places that I felt comfortable going. So I said to myself, I really want to continue in physics. So how do I continue? How am I able to do this? So talking to my research advisor, and some people at APS, Professor Dickerson, I don't know if you know him, at Vanderbilt, they encouraged me to take a year in between grad school, and my advisor helped me to find a position at Hampton doing more experimental hardware type research at Hampton. And when you're considering this kind of decision, it's really good to make a list of pros and cons. You can address your application weaknesses during that year off if you're going to reapply. You can take a look at your application and see what things you need to strengthen. You can retake GREs if you need to. You can have more fulfilled research experience. Also, it's a good idea to get a taste of what the research life is like, because it's very much not like the classroom. Most of the time in undergrad in physics is spent in class, learning things via lectures, and that's not how graduate school is. You're mostly in lab, getting much more hands-on and exploring more at the frontiers of knowledge. However, there are some drawbacks to this, depending on who you are and what you do, but it's good to have a balanced view of this. So I have a few pictures here of, this is the Marnova group at Hampton that I worked with developing. We actually built the detector that was installed at Fermilab, and I was actually able to go to Fermilab and help install the detector, and also to train the technicians there on how to better build and maintain the detector, which is a good experience that you wouldn't actually ever get in undergrad. Having that responsibility to go off-site and train and instruct people on how to manage the detector. So that's another benefit to taking a year off doing this kind of work. So here's one of the detector planes we built. The maneuver detector is about 100 of these planes stacked horizontally and placed in front of a beam. And these plates light up when particles interact with them, and you can track the interactions this way. So I went into this year knowing that I wanted to reapply to grad school the next year. And I reapplied and I got in, thankfully. And I had the choice of several different graduate schools. And so I have a list here of things I considered when you're choosing a graduate school. Now, most graduate schools if you get in, will fly you out for a visit, so you can meet potential advisors, get a sense for the location, and talk to current graduate students. All of these things are extremely important. You want to have a sense of the location. Is it urban? Is it rural? Close or far away from your family? That's important because you need a support system. In graduate school, you need to have a life off campus. Also, what kind of funding do they provide? Do you have to TA? Do they have fellowships? Do you bring your own funding? All of these things are things to discuss at the visit at the graduate school that you're considering. And secondly, and thirdly, you want to talk to current graduate students there to get a sense for the culture of the department. What is it a large department? Is it a small department? What is it like? Do they have a comp exam? How long do students generally take to graduate? All of these kinds of questions are questions you want to ask to current graduate students at the visit. If they don't give you time at the visit to talk to current graduate students, you want to ask, and they'll usually accommodate you. If they don't accommodate you, you have to ask why they're not doing that. So now that you're in graduate school, you're faced with the first year. So generally this varies by program. Generally you have a first year of core classes like graduate quantum mechanics, electromagnetics, classical mechanics, and statistical mechanics that you have to take and do well in. And then you have to pass the qualifying exam, which is generally at the end of your first year or the beginning of your second year. Some schools don't have this. For example, Columbia doesn't have it, but a lot of schools, especially on the West Coast, still have these qualifying exams. Now, I want to pause here to talk a little bit about the qualifying exam because I've noticed that minority students especially tend to have difficulty with this, first major hurdle of graduate school. I don't think there's no bias necessarily, but it's just that a lot of minority students, racially and gender, tend to have problems passing the comp exam. So you want to have a focused sort of space and time away for a month or so, really preparing for this exam. And you can really find out early whether the exam is used to weed out students, to exclude students from continuing, or whether it's just another step in the continuation. Some schools use the exam to weed out students, and you want to avoid that. So after your first year, you just generally join a research group and start doing research, which is what you're in grad school to do. Now, for me, I came in having my experience in neutrino physics and particle physics, but I wanted to switch fields. I chose UCLA specifically because there were people in both neutrino physics and in soft condensed matter or biophysics that I wanted to work with. And I ended up in Professor Zucchi's group, where we look at the material properties of proteins. Now, this picture I have in front of you is a molecule of the type that I'm constructing in the lab right now. We take a protein, which is that blue part in the middle there, that blue U-shaped molecule, and we attach a DNA strand to it, that green molecule. And because the DNA strand is bent, it applies stress to the protein. So I'm actually pulling on it in the direction of the strand. And this causes changes in mechanics of the protein, of how the protein works. And we can measure that effect on the chemistry, how well it catalyzes the reaction that it's meant to catalyze. And this connection between mechanics and chemistry is very important because we're learning proteins are not the static blocks that you may have learned about in high school or in college. They have actual dynamic, time-dependent properties that we're trying to understand by experiments like this and experiments and other experiments in the lab. So with that, I will end my talk, and thank you.
Thank you, Collin. That was very interesting. we can change the screen, that would be great. All right, so to ask the both of you, it's really interesting that both of you have actually taken, I'm not sure if it's a traditional route or not, but both of you took a different route than many grad students to graduate school. And I was wondering, do you think there's something or someone that could have influenced you in undergrad, or something that you could have done as an undergrad that might have created a better situation for you, or a different situation for you, so that you might have gone straight into graduate school? Do you think there was some advising that was missing, or you know, anything that maybe was lacking? Either of you can.
Well, I guess I'll start. It's, for me, it wasn't necessarily any lack in advising or mentorship that caused me to take a year off. For me, it specifically was the fact that I wanted, that, well, I was interested in getting a more hands-on experimental experience, which I didn't get in undergrad. I came in wanting to do theory, so I was able to do theory, theoretical physics in undergrad. But by the time I had finished, I wanted to switch to experiment. And before I did that in grad school, I wanted to get a sort of taste of what that was like in my field of neutrino physics, and decide whether or not I wanted to switch. So that was really why I decided to take that gap year in between there.
Sure. Ximena, you mentioned that you weren't very happy. Go ahead.
No, so at Vassar I was very happy, and I really liked astronomy research, but I didn't know what grad school was like. Since I was at a small liberal arts college, I didn't know any grad students, I didn't know anything related to that. So I think if I would have had any experience maybe at a research university or talking with grad students or something, then I would have been less hesitant of astronomy, but no.
Did either of you have a mentor or several mentors that you relied on for advice or just guidance along the way? And they could be within your school or outside of your school professionally that could that gave you any kind of guidance. And can you speak to the importance of that if, in fact, you had some mentors?
Well, I was lucky to have at least two very important and dedicated mentors to me. First was my undergrad advisor, the head of the lab I worked in, Professor Bonnie Fleming. She was really great in sort of not only guiding me through the research and helping me to understand what I was doing and to sort of craft it into something that was publishable and worth a while. So when I was approaching the end of my senior year and was considering applying to grad school, she really sat down with me and talked to me over, her experience and what it was like, and she also helped me to find this position at Hampton that I would be able to do what I wanted to do during that year off. So that's the first real important mentor to me. Secondly, was at the APS, Professor Dickerson at Vanderbilt. He was my mentor for the minority scholarship program, and he was also really quite helpful to me. I had several talks with him just about his experience in physics and in graduate school that really helped me to understand it and to desire to continue in physics. So.
Great. Ximena?
Yeah, for me, I can think of two people in undergrad. My astronomy professor, Debbie L. McGreen, she is just a role model for me. I think she's the superwoman. She can do everything, and she has a family, and she's a great scientist. Yeah. She was the president of the Astronomical American Society. She does everything, and she's a normal person. So it just, I don't know, there are always questions about like women in science and all that, and it was, for me, she was like my role model. Me, like, yes, it is possible to be a successful scientist and still have a normal life. And she was always very supportive of whatever I wanted to do. So she's really great. And then now Marcel, who was in charge of the bridge program, whenever I have a question about anything, professional life, conferences, whatever, I go talk with him, even though we don't do any research. He does very different research than what I do, but he's just a good person to go talk to. So, yeah.
Great. We have a sort of a statement from someone. One of our audience members really appreciated your presentations and thought you were really good, both of you. And they talked about the fact that both of you sort of hit a little bit of a rough patch throughout your educational career, and I think that's actually more common than not. But it shows a lot of character that both of you overcame your obstacles and ended up in grad school. And so they're wondering, you know, in light of your experience, what advice would you give to young people, either in high school or beginning college? Would you recommend entering physics or astronomy grad school? And is there anything that could have made things easier for you or allowed you to progress better? So advice for young people. Would you recommend physics or astronomy? Collin?
Okay.
I'll let Ximena go ahead.
Go ahead.
I think if they really love it, yes. I don't think it's an easy career choice if you're not in love with it. But if you're in love with it, go for it. But if you're like, oh, maybe physics is cool. But yes, it's cool, but it's very hard as well. And career options are very limited after graduating. So there are some issues. And I wish kind of that during undergrad they would have told me that. I think I would have still pursued it, but I really had no idea that getting a faculty job would be so difficult, for example. And they don't really tell you that before getting to grad school. And I think they should be faculty should be more upfront about it during undergrad. But.
Yeah, I echo what Ximena said, in that if you really enjoy it, if it's something that if science is something that you can't see yourself doing without, then maybe grad school is a place for you. But so this is why I talk so much about motivation at the beginning of my presentation, because really during those times when your experiment is not working, when when things are not going well, you really have to sort of back up and think about, why are you here? Is it still worthwhile doing? And these are the sort of questions that you have to continue to ask yourself over and over again as you continue and pursue. That's again why I think research experience in undergrad is so important, because it gives you sort of that first problem that you get. You're going to bang your head against the wall for a while, trying to get yourself to that next level of thinking about something more modern and more current. That's not a problem in your mechanics class or something. So you need to have that research experience and also that love and passion for continuing to go on for 6 years in graduate school, which is a lot of time.
So along that vein, did either of you encounter anyone or anything, I suppose? I'm sure you encountered things that may have discouraged you, but did you ever encounter anyone that was a little bit, or who was a little bit discouraging about you continuing on in physics or astronomy? And if so, how did you handle it?
Well, my experience, I never had anyone who thought I couldn't do it because I wasn't good enough. That's not the question that a lot of people that some people are. That's not something that's come up in my experience, thankfully. But I have had people who who have asked me, do you still want to continue? You don't have to stay in grad school if you don't want to. So things like that. But again, you have to be inwardly motivated in yourself. You can't let what other people say sort of dictate to you or control. What are you thinking?
Right, right.
Yeah.
So did either of you take the GRE?
Yes.
I did, yes.
Good. And so how did you prepare for that? Did you study alone? Did you study with others? If you can break down maybe a quick strategy on how students can study for that, what was the experience like?
So I took it twice. The first time I did terribly, very poorly. And I think it was because I studied alone. And it's really hard to find time to study because you're busy doing whatever you're doing during undergrad, or if you're doing research or whatever, you're busy. So it's really difficult to set some time aside. So I think having a study group is great. So Columbia, I took it when I was a bridge scholar here at Columbia. Columbia organizes in the physics department, professor organizes a study group, and those were really great and helpful. And that made me, for at least 1 hour every week, study for the physics GRE. So I think having some sort of study group where you really commit some time, it's much better than doing it on your own. But that was just...
Yeah, I agree with that because I also took it twice. But the second time I studied alone, not as much as I did the first time, so I didn't do much better. So it was roughly the same score both times. But yeah, again, the GRE is, I think for most schools, is kind of a benchmark. Once you get above a certain score, your score doesn't matter. It doesn't matter whether you get a 990 or 980. Right? Once above a certain score, they look at the rest of the application, especially recommendations from research advisors and stuff.
Right. So once you got in and you for the first time stepped into the physics department or astronomy department, what do you think? What was the biggest change besides the fact that as a graduate student, you're often more in the lab. But I think as a first-year graduate student, you're still taking courses. Is that correct?
Yeah.
You took a lot of courses. So what was the biggest change for you from undergraduate to graduate school?
For me, it was just because before in undergrad, during my undergrad experiences, the PI would tell me, so this is the project, this is what you have to do. Kind of like gave me some steps of how to achieve something. But in grad school, it's really, maybe you're given a project and you're supposed to figure it out. So having that initiative and having the motivation is very different than when you're an undergrad. Because undergrad, it's a good research experience, of course, but I think professors are more involved. In grad school, professors are busy, and it's just they're more hands-off. So that was an interesting transition for me. But.
Yeah. Even in the coursework, for example, that first year that I was mostly taking classes and not doing any research, the coursework it's different because in undergrad, at least in my experience, I had, we sort of had a group of people who would, get together and do the problems and try and figure out what we were doing. In graduate school, at least the classes for me were much smaller, and so it was much more about understanding it yourself and really sort of getting into the meat of it on your own without much discussion with others. At least in the coursework. But Ximena is right. The lab experience, the research experience is much different. It's much more self-motivated. your advisor will say, what do you think? Or why don't you figure out what the next step is? Or figure out this new kind of experiment. And that's not something that you get in undergrad.
Right.
Yeah. And also in undergrad, the professor usually knows more, always.
Yeah, right.
And the professor can always answer your questions. And in grad school, many times, my advisor would be like, I don't know. You have to figure it out because I really don't know. So you're more like a peer than rather like, more like in an undergrad, but it's an interesting experience.
Right. So I think we have a comment about careers, and Crystal, if you want to talk about that just for a minute.
Yeah, thanks, Arlene. I just wanted to chime in a little bit regarding the earlier conversation about careers. I think the statement that was made was that it's limited, that a physics degree is limited in career options. I will have to say that's definitely true if you are only considering academic careers. There are a relatively small number of academic faculty positions available, but as a matter of fact, 50% of physics bachelors actually go straight into the workforce right after graduation, and industry and private sector actually employ about half of all physics PhDs. So one thing to just kind of bear in mind, too, when thinking about careers is that, in fact, physics is a highly employable major, just not if your end goal is to become an academic researcher. So that's an important distinction.
Right.
Thank you.
Yes, I completely agree with that. Yeah, when I said it, in undergrad, when you think about grad school, you think about the end point is to become a professor, right? So they don't really tell you about other career options, but I think universities are slowly making their students aware that there are other options besides academia. So yes, that's a very valid point.
That's right. I think we at the APS, and Crystal in particular, we're trying to really hammer that message home so that graduate students have a better expectation of what their future can be. And there are lots of really important problems out there to help solve, and physicists and astronomers, you can do those things in different areas, not just academia. You can work in a national lab, you can work in a corporation, you can start your own company. And this is why we think that it's important not only to get your scientific information and do your lab work and solve the scientific problems, but also to get some understanding of maybe if you want to start a company, get some business courses behind you, learn how to write technical papers, learn things like proposal writing, because if you do end up in academia, you will very likely write proposals. And sort of, it's really important to get that funding for your research. And while we're talking about funding, I did want to ask both of you, what kinds of, well, basically, how do you pay for graduate school?
So they pay you, which is nice.
Yeah.
So at least how it works at Columbia, we teach for the first few years. So the university pays us, and then after your third year, your advisor pays you with their grant. So I don't have to pay to go to school, which is very nice. Of course, the stipend is very small, but it's very livable, and I enjoy New York, and I have a fun life, I think. So.
Yeah, it's similar for me at UCLA in that you generally TA or teach for a few years, and then if you're a group, your research group has funding, they will put you on research on GSR, and you'll become a researcher for them. I'm actually teaching most of the time now because I enjoy teaching, and I like I want to get better at it. So I'm actually teaching a couple quarters out of every year, even though I don't have to necessarily. Also, you can apply for fellowships, and you can bring funding with you, which is always great, especially to strengthen your application. So.
Right.
And that also helps with in the proposal writing that you were talking about earlier, right? Understanding what that looks like.
Right. I wanted you to get that out because I've realized that a lot of students didn't know that they could be paid to go to graduate school. So that's a pretty good perk, I would say.
Yeah, I mean it's livable, but it's small. Yeah.
Yeah.
Absolutely. So is there any other advice that you would give to undergrads, juniors, seniors, even sophomores that are thinking about graduate school and not really sure if that's something that they want to pursue?
I think definitely get some research experience because research is not for everyone. So maybe you might fall in love with it, or you might realize it's really not for you. And in your research experience, talk with experienced physicists or even grad students to see what it's like to be in grad school, and then as you move along in your career. So.
Yeah, I think if you're a sophomore or a junior, you should really look into getting some research experience because that'll give you a good idea of what's going on in grad school. If you're a senior and you already have some and you're thinking about applying, you should certainly apply. It's generally a good idea. If you're interested, you don't have to go. If you can also consider taking some time in between. If you still feel like you don't know what it's like and you don't know if you want to do research. And then once you're at schools, talk to people, talk to students, talk to professors, get a sense of what it's like and what things are going on there. Right?
Yeah. And even I should mention that many universities now have bridge programs, so that's a great transition into grad school. So not only you take more class in case you feel your background is not strong enough, you'll take classes. If we think you haven't done enough research, you'll do research with someone. You'll likely get a paper out of it. Your application to grad school will look much better. And also many of these bridge programs offer GRE prep and public speaking things and stuff like that. So look into those too.
Ximena, that's a great segue for us because actually the APS has just created a bridge program that will help other universities to build bridge programs for students who may have gone to smaller schools that didn't offer all the courses that they would need to really be successful in graduate school, or students who came to the decision late and didn't take those courses, or students who just didn't do as well as they would have liked and they still have some gaps in their learning. We've created a program, and for those of you who are interested in that, the program website is www.apsbridgeprogram.org, and you can go on there and read about it, and we will be taking applications probably next spring. So I think we're just about out of time, and if either of you could just speak for we have about 1 minute, just to talk about the other professional development things that you do as a graduate student, maybe presenting at conferences or giving posters or what have you. And how important is that, and is that something you think students should do?
Yeah, going to conferences is really important. I think this is something I forgot to mention in my presentation. Yeah, promoting your work, even getting it out there, talking to other people is a really good way of networking, as Ximena said, of even getting ideas for what to do next, of getting your name out there so that when people have postdoc positions, they'll think of you, or something like that. So going to conferences, giving a poster, giving a talk is really important to do. Because if you do your work but you don't present it to anyone, how are they going to know what's going on, right? So you have to promote your work.
So I think it's important to try to publish papers as much as you can. And then if you have a paper, make sure you're presenting your results somewhere. And also you can do some local networking. So many departments have a ton of seminars, colloquia, etc. So if your work is related to the speaker's work, you should talk to that person and tell them about your work. That way this person gets to know you and gets to know your work. And then, again, if you're looking for postdocs, that would be really helpful if they know you.
So I think we need to conclude the program, but I want to thank you both for all of your insights, for sharing some of your research, and for definitely sharing your experiences as you've gone from your undergraduate years through your bridge, or I guess your program was a bridge program as well, Collin.
Yeah.
And into graduate school, and we wish you the greatest success, and we thank you for presenting to us today. And I'm going to turn it over to Crystal. So thank you.
Yes, and yes, I would also like to join Arlene in saying thanks to our speakers. It's wonderful to hear from you, and it was a really, really nice presentation. So we do, if there are any additional questions that you have, you are welcome to follow up. You can send an email to webinars@aps.org. That's easy to remember, and I can make sure that your questions are forwarded for comment to our speakers. As we stated earlier, the slides of the presentations will be made available on the main page for this webinar, which is where I think you were when to actually sign up for the webinar. A recording of the presentation will also appear on this same page, but we do ask that you please allow us 24 hours for video upload. You will also receive an email from us containing a link to the recording of today's presentation. And with that, I guess that wraps up our event. Thanks again so much for joining us, and we will see you all next time. Okay, bye-bye.
Bye.
Thanks. Bye.
Thank you. Bye.
Bye.
The